Hello, so in this demonstration we will focus on this part that will be our target sample, and we'll create two different point distributions with different densities. The purpose for this is to understand how or which tool to use regarding the density. So the first sampling that was used low density, and opposed is the second sample where we have a really fine density about the mesh. So we will compare both these samplings and see the different tools available for generating Fe from this sampling. So first step or first tool is to use a shrink wrap method including hexa elements. We have to make sure this option is checked in order to have the mesh. So first, let's try to identify, it's not pretty simple, but let's try to identify the average size or the average length between nodes. So you can use the measure tools in order to achieve this. So once you return, or once you have identified one mesh size, you can go to the shrink wrap panel, use points as inputs, geometry, and specify the target mesh size. Then think about checking the generate solid mesh, and click on mesh. You see that we get kind of mesh, and the important point is that try to play with different mesh size to see the different kind of results you can expect. And yeah, you may need to tune a little bit the target mesh size in order to get a good result. So if you go too fine, you may create some localized areas. If you specify too large size, you may have something too big. So you have to tune a little bit in order to find the best option. So here I tuned a little bit, and for this specific case, 0.5 was the best. Here, just as a last information, I'm saving the mesh as a part representation in HyperMesh, which allows me to store the mesh into the HyperMesh file for further use. And when the representation is saved, I can safely remove the elements and I can load them back at any time. So now let's have a look at the second tool, which is Facet from nodes. It requires some nodes as input, so I will use the small macro in order to create nodes from all the points. This macro I posted on community, so if you want to retrieve it, you can find it back on community. So let's use this macro to create node from points in order to generate the nodes. So I can just drag and drop the macro inside HyperMesh, select my points, and I can generate the nodes. So here they are, and now I can select the nodes. And this tool also requires a target size, so an average distance between nodes. So let's use it. And we see here that we have something which is not relevant. And I can try to tune a little bit the mesh size as I did for the shrink wrap. And neither of the tests will bring a satisfying mesh. So for low distribution, create facet from nodes may not be relevant. So instead of, for low density, we will focus rather on shrink wrap algorithm. Now let's switch to the large density distribution. And let's start with shrink wrap. So let's take the points and play with the element size again. So it's more accurate with a higher density. but as a matter of sharp edges, sorry, it is not able to really capture these sharp edges. We so always have something smooth and nothing that is can be represent the sharp side of what we had at the beginning. So if you have something smooth as a cloud of points, as a distribution, this should be fine. But if you want to capture sharp edges, this may be not enough. So let me save it again as a representation. And let me now go to Facet from nodes. So I will first delete the elements. Again, use the macro in order to generate points, not from points, sorry. And once the macro run, I will be able to run the facet from nodes. So here, purposely, I skipped the macro process, which was somehow 30 seconds. And let's run the facet from nodes. So again, I can set the size, and we have a best capture of the sharp edges, but there are some unwanted facets that will need to be removed. Especially there are some which starts around the parable, let's say, and that we will need to remove. But besides of these facets, we have some things which somehow better capture the sharp edges. So let's try with a different mesh size. And most of the time, even with dealing with a different size, we still get some unwanted elements, but maybe we can control them a little bit better. And here we got something which seems pretty close to the initial representation of our geometry. So as a last step, let's say now that you want to export this as a CAD geometry. So right now what you have is finite elements. So we need to move from CAD to finite elements. And in order to show you, I picked this shrink wrap, which is a little bit smooth in order not to spend too much time on surface correction. So first step, especially if you deal with shrink wrap, will be to export or to extract the skin of a solid. So to do so, you can go on the loop here or Control F and search for faces and look for panel faces in 2021.2. Then you can select your component and find faces. And you see that we have a new connector component, which I will make current, and I will hide the original one. Now, and this option, this step, we can do it both for the 2D skin of the shrink wrap or the facet from node approach. You can go for from FE, so panels from FE, and you can select your elements and say that you want to create surfaces from your elements. You can play with the complexity, but the higher the surface complexity, the larger the processing time. So for this kind of mesh, this should be pretty straightforward, and there are some areas where the algorithm fails to create some surfaces. So let's focus on this point. We have this patch here. So let's go to geometry, surfaces, patch. Let's see if we can patch it by checking the edges and validate. Okay, here it's better now. We may have to stitch lines together just to make sure that, so here you can pick the point, bring it to the other one, and my bad, I forgot to remove an option maybe first, which was to disable. Okay, so that was fine, just as the mention in the preferences before doing some geometry modification, make sure that in the meshing, your cut topology revision is set to disassociate mesh. And let's do the same here. We can stitch, okay, this one, and I want to validate. Okay, it didn't go well, so let's pick this one and move it to the other one. If we can. Okay, so here we have to take this point and to bring here, possibly. Okay, let's have a look if we see other defects. It seems it's okay. So now, if we want to, either we can export this to the CAD, or we can create a solid if we want a solid, and we can click on bonding. It seems that we'll still have some defects. So I did some extra corrections in addition of the one that I demoed in the presentation, and then I can go to the solids just to create a bonding surface, and then you see that I can create my solid. So either you need to create some FE, some 2D surfaces, and you just have to look for the from FE feature, and keep in mind that you need to extract the external faces first if you want to deal with solid on mesh, and then you can create this from FE. And for the export, you just have to file, export geometry model, and choose your preferred format between the different format available: IGES, GIT, Parasolid. Generally, among step IGS and Parasolid, we tend to recommend Parasolid.